What we're doing here, we are doing systems of equations. So I'm going to break you into groups. All right, our first group for the graphing, Sanum and Brandon. I want you going into this corner. Just pick 2 seats. If you need to rearrange your desks, you can do so. And then I need a substitution group, which will be Harrison, Peter, Kevin. You guys stay in this area right here. So maybe these 3 desks right here. So Harry, move right there. Our last group is going to be solving systems by elimination. So it'll be Cloud, Hulk, Borowski, this group over here. All right, these 4 desks in the back corner. All right, so yeah, take your books, take your notebooks, and you're going to need a writing utensil. Okay? The object of what we're doing here, all right, everybody has a different way to solve systems. We have our graphing group, our substitution group, and our elimination group. Okay? You've been placed into these groups based on what I believe you will thrive and come up with the best possible way to solve these systems. Okay? So, with the graphing group, you're going to open up your books to section 6.1, and you're going to choose 2 of the graphing problems. Your choice. You're going to graph them and get ready to present them for the class. Okay? The substitution group, you are coming up in section 6.2. You're coming up with 2 problems, all right, of substitution. Okay? You're providing the steps that you use with substitution. Make sure one of your substitution problems, okay, is a little more difficult. So choose it from a higher number in the homework problems. Same with elimination. Yours is 6.3. You choose 2 problems. Okay. With the elimination, make sure you choose a problem in which you multiply both of your equations by one of the factors. Okay. And with your group, you're coming up with your list also. Okay. So make sure you have the 2 problems solved and your list of what you're doing. Okay. And
steps?
Yep. Steps of how you solve these problems. Okay? So you can get into your groups, turn your desks around if you need to work together. Alright? Because you guys have to come up with your lists of how you solve these problems. Alright, we are going to be presenting these in 10 minutes. Alright, so you have 10 minutes to do these problems. Alright? So make sure you guys work together, effective and efficient.
Step 1. I just want to eliminate one variable.
Do you each take the problem?
Yeah, I'm going to do it 14.
I think in step you gotta check if like the sum of like any coefficient equals to 0.
Steps here.
Yeah, you have to find like an easier problem and then a more difficult problem.
Yeah,
Where's the whole
easy problem steps. Make sure you know one of these numbers.
Yeah, one of those first 3 you do the lesson checks.
You just solve and check.
Yeah, that's fine.
Okay.
Yes. Yeah.
So
I mean-
first you have to graph it, don't you?
You mean
Let me find this from
this one already be set up
This
for
is
you.
the-
You can do that.
slope
You
is
can have
the
one,
intersect?
like, I'm assuming this one's
So,
good.
for the 13.
Yeah, that one, yeah.
Oh,
Yeah, so this one,
Well, and then we
June
use
for
the
one.
120. That looks kind of good.
Yeah.
That one.
Yeah.
Different coefficients. So
That's good.
we'll have to like make more steps because.
Yeah, we'll have
this
to
one-
multiply this by 5.
Yeah.
Y is the intersection.
Make sure you guys have someone doing some problems and then someone writing the next steps too.
The steps are already written.
You are
You just grab it as you
convinced
move.
why elimination is the answer to the video.
You can solve it because the problem is right.
Yeah. That's like your number one.
You just need to do like 3.
Well, you, you can solve any system.
The easiest way to solve any problem whatsoever.
It is, but you can also solve graphing. You can solve any system with graphing also.
With elimination, you don't.
Correct. But you're trying to persuade. Why? Because,
You
well,
don't
I don't wanna
have
give
to
you the answers. Wait, okay. I mean, you did some of those problems too, where your intersection point was way
Yeah.
off the charts. I mean, it's an estimation at that point, you know what I mean?
So Y equals negative, so Y equals negative X. You're on this one. If Y equals negative X. Y equals negative X. I just found Y. So the Y intercept would be 0. Right? And then just look at the negative Y. Oh, yeah.
Maybe after he writes it out. After he writes it out. Right. Right. So let him do everything. And you'll have 2 pages, so you can use it as much.
So in the intersection points, you have to
Oh,
create
I'm going to be, I'm going to be asking you questions.
So for one page, do we like use one problem and then write the stuff on the first page?
Sure.
And then the next page, since we're multiplying, so for the.
Sure.
Well, wait.
Absolutely.
Right.
No, we have not.
Well, people said I never
You guys do all right?
I think the answer is you want us to put S equals the one comment to
Sure, that's fine. I mean, it's your graph, so you can do what.
Oh, do you want us to write on the board and stuff?
Yeah.
Okay.
Yeah, but you're gonna present it up here. That's why I have these grids.
Okay. Alright, yeah, so you got your answer. 2, 2. So I got 2. You got 2, negative 2. So, who wants to do this one? Because these are easy.
You guys got about 2 more minutes?
So, you plug it back into one of the problems, right? You don't plug plug it
Here.
back into the whole thing. No, not here for this one.
For this one.
If you were solving, like they so what variable did you solve? Solve for x.
Yeah, so you plug it in and then so y equals 3. And that's the answer. And then for this one, you gotta plug back in for the original. So actually, 4, and then that's the answer here. So for the steps, you eliminate one variable. What?
Like I just need for the second problem.
For the steps, you look for the like similar, same coefficients first. Because if these two were the same, then you would eliminate them first. So you gotta look for to no optional step.
So Alex, you want to say the second problem?
Am I just solving them and
Yeah, you're
you
just
guys
solving
list the
yeah.
steps?
Yeah.
Okay.
You want to list the second one?
Yeah, sure.
So Hulk, you gotta remember that you gotta multiply the
Yeah, both
That's what you
equations by
yeah.
the
to find a common multiple that you can subtract. And then so I'll
Alright,
solve
start
them.
wrapping it up, guys. Start wrapping it up. You got about 1 minute left. Start wrapping it up. You guys are doing very well.
What do you want it to be?
find the same coefficient first. It's like optional. So if we didn't find the same coefficient, then we multiply. Find
And then eliminate a variable.
yeah, like we go to
Check. So we're doing, I'll solve one equation on one side, you'll write the steps, and then we'll go to a new slide, and I'll solve this equation, and then you'll write the steps.
yeah, we gotta like explain it to them.
And then,
We gotta like talk about it.
Mr. Hendrick, do we
Yes,
have to, when we're trying to persuade them to shoot, like, that elimination is the best one, we don't have to write anything on the board, right?
You can. You can do whatever you want.
Okay.
This
We'll
is
just-
we
this is
have
We'll
what you
just
want.
talk to you.
We have to explain it like how we like did it.
Sure, absolutely.
We'll talk about, I'll persuade them. I'll say like, because the intersection point what?
Write it down.
All right, guys. Let's bring it back together. All right, can you fix your desks back and get back to your seats? Yes, back to your normal seats, please. All right, with systems of equations, all right, you always have your own special way of solving systems, all right? With algebra, they specifically give you 3 different ways to solve systems, right? Some ways students enjoy more than other ways, okay? Personally, okay, this entire year, I've been giving you my way of solving equations, okay? My steps, okay? My personal steps that I follow every single time so that I don't get the problem wrong, okay? I was doing that with factoring, I was doing it with FOIL, everybody remembers it, okay? But with systems of equations, the book specifically says there's 3 different ways, right? I broke you up into your 3 different groups. We're going to hear from each group on how they solved it, right? So first, let's bring up our graphing group, all right, Brandon and Griffin. If you have trouble with the board, just let me know. Absolutely, go ahead.
So we did graphing, and then our problem was, you right up here? No. It was was y equals x minus 4 and y equals negative x. Okay, so first you have to figure out your slope and your y-intercept. So your slope for this one is going to be 1, so m equals 1, and then y-intercept is negative 4, so you're going to graph that, so x minus 4, so you start at negative 4, 1, 2, 3, 4, oh, negative, here's our point, and then you go up 1, right 1, 1, right 1, 1, right 1, and then you go down, but can you scroll down on this? And then our for y equals negative x, your slope is negative 1, and then your y-intercept, since there is no number on the equation, you can put it's 0, so y equals 0, so you start at 0, and then you go down 1, right 1, down 1, right 1, down 1, right 1. I'm gonna make a line for these, forgot about that. Up 1, left 1. And so your intersection point is 2, negative 2. And that's your answer.
Well, what is the 2, what's 2, negative 2?
The solution. To
The solution of your system,
Yeah, so if you plug it in, you'll get
where the
correct.
2 lines intersect.
Yeah.
Okay. Now, so, well, let's look at, Brandon, you do push that forward arrow at the top left?
This one?
Nope. You do your graph.
Okay, so for my graph, I had y equals negative x plus 3, and y equals x plus 1. So let's start with the first one. Your slope would be negative 1, so m equals negative 1, and your y-intercept would be 3, so y equals 3. So you start at 3 up from 0, and you would go down 1 and over 1, down 1 and over 1, and you would draw a line. Your next line would be starting at 1, so you have y equals 1, and your intercept would be, or I'm sorry, your slope would be 1 as well. So m equals 1. So you would start at 1, and you would go up 1 over 1, up 1 over 1, and just one more. So your intersection of the 2 lines would be right here, and that would be, so this is our x-intercept, this is our y line, so it would be 1, comma, it's 2 up, so it would be 2.
Alright, so, with both of our graphs that we have, or that you guys chose to do, your intersection point is somewhere on this grid, right? What were to happen if your intersection point was off this grid, not on this grid, and you can't tell what your solution is? Why would someone want to graph if that was the case?
If it was off of the grid, you could either estimate, or you could just expand the graph. The thing I like about graphing is like it's a visual for the problem, so you get to kind of see what the problem is.
Okay. job, guys. Good job. Alright, next group. Our substitution group.
You do it, and I'll explain the steps. You write it and I'll explain the
Okay.
steps.
So this will be problem 11, and you start out with x plus y equals 8, and then y equals 3x. So first off, you want to isolate this y, so you can subtract the x. So we'll go y equals 8 minus x. So then you can just scribble out that. That's not important anymore. Okay, so now these, you keep your two y's, and then you can take this 3x and put it here, or you can take this 8 minus x, put it there. So we'll go 3x minus 8. There's 3x equals 8 minus x. So then you add this x over here. So 4x equals 8. Then you divide x equals 2. You get that because 8 divided by 4 equals 2. So 8 will be your, 2 will be your slope, because x equals the slope. So now you can go into either problem. I'll go into the y equals 3x. So now it's y equals 3 times 2, and that's y equals 6. So that will be your intersection. So 2 comma 6.
Just for clarity, 2 is not the slope. 2 is
The x. 2 is the x.
yeah, 2 is the
2
x
is
value.
x.
Yeah, yeah.
Yeah.
It's not the slope though.
Okay.
All right, do the next problem and then push the forward arrow. Oh, push the back arrow real quick. And then push. There you go.
Okay, so we start off with 7x minus 2y equals 1 and 2y equals x minus 1. And I solve for x first, so you add 1 to both sides. And you get 2y plus 1 equals x. And then you can plug that into either of them, and I plugged it into that one. The top, 7x minus 2y equals 1, so that becomes 7 times 2y plus 1 minus 2y equals 1. And then you distribute the 7 to the 2y and the 1, so it's 14y plus 7 minus 2y equals 1. And then you can combine like terms here, so it's 12y plus 7 equals 1. And then you subtract the 7 on both sides, and you get 12y equals negative 6. And then you divide the 12 on both sides, and you get y equals negative half. And so after you get that, you can write that in your answer. And then you plug that back in to either of the problems, and you get, let's do this one, you get 2 times a negative 1/2 equals x plus 1. So that's a negative 1 equals x plus 1. Or sorry, that's a 1, that's a positive 1 equals x plus 1, and then you subtract 1 on both sides. X equals
All right, so what were the steps that you used to solve these problems?
The first step is you would substitute the x or the y value into the top equation or the bottom equation, and then you solve that equation, and then the answer you get from that equation, you have to plug into.
Well, what happens if you can't solve? What happens if the first step is not just plugging in right away?
You have
For
to
instance,
simplify.
Kevin's was you can plug right in.
Right,
Pete's was not.
right. You have to
So-
simplify that first,
Okay.
and then you get once you get that answer, you plug it in, and you solve it, and then you keep plugging it in, keep plugging the answer you get the first time, plug into to the original equation, and you get another answer, the x or the y, whichever one, and then that's your answer, x comma y.
Okay. I have another question for you, but I'll wait till after elimination goes.
Mm.
Thank you.
I'll save enough room so you guys can write this up. For our group, I'll be doing the problems, and then Alex will be writing on the steps. The first one you had was pretty simple. It was already set up for you. So these two cancel out automatically. So it's 7x. That's x, and then you have to plug it back in to find y. Your answer has to be in an ordered pair. So that's the first answer.
So, I'm gonna break the steps down.
It's up to you.
So we're starting out with a negative 2y plus 2y. We can subtract, add to get rid of that. So we add all of them together. Those automatically cancel out, and then we divide 7x. So divide 7, and we get x equals 2. And we plug the 2 in up here for the 3x, and then so we solve that. Divide -2 by -2, we get y equals 3, and then we put them in an order pair. 2, 3.
And then the next problem we had was harder. So you have to find the same coefficients for some of them. These cancel out, and you add these together. Brings up to 67y.
problem here is a bit more harder than the previous one, because, in the previous one, from the start, we could, subtract the x values. Here, we gotta find, the common multiple, so we find, here 15x minus 27y and minus 15x minus 40y, so we add both of the equations, and, we get the answer here, which is 7y, and then in the second equation we find the x value, and so we plug it in, plug 7 into the second equation, because it's much easier than the first one, and so we find it right here, then we get the answer, and our answer for this equation is, for both the equations is 4 and 7.
Okay, so why is the elimination method, in your opinion, out of the three methods, graphing, substitution, elimination, why is that the better method to use for, I mean, let's say this problem or any problem?
Compared to substitution, you don't always have the same coefficients, so they don't always cancel out, so by using elimination you can do that.
Okay.
And for graphing, if you have like a more complex equation like these two, the intersection point of the graph is usually way up. So you either have to estimate it, like Ronan said, extend the graph by a lot.
Okay.
So that's why this is easier too.
Okay. All right. Good job, guys. As you can see, the three different ways to solve systems, each way uses a different technique in order to come to your conclusion. Okay. I always teach, well, you know, mostly elimination. Elimination can be used for any system, but with respect to the groups that you were in, the graphing group came up with a solution that probably was faster than this elimination method, okay? Just because sometimes the point could be lying off of the line, or off of the graph, all right, doesn't necessarily mean that you should just not do that, not do the graphing, okay? In the long run, I would agree with what the elimination group is saying as far as this being the best way, all right, to solve these systems. But it's nice to see three different methods to solve systems in three different approaches, right? Each group got a different assignment as far as what they were supposed to do, which was nice. But I appreciate everyone's contribution. You should be proud. Every one of these were spot on. So I'm very excited about your knowledge as far as systems of equations goes. Are there any questions with this?
So it all matters how each system is set up?
Exactly. It depends on how the system is set up as far as how you're going to approach it. Okay. So, all right. Well, thank you.